IPE questions in this gravitation chapter. So in this gravitation chapter we have the weightages is only 4 marks. So we can expect the 4 marks questions, 9 questions in IPE from this gravitation. In that the first question is universal law of gravitation. So universal law of gravitation is having the 4 marks questions. There we are writing only 2 statements. Universal law of gravitation. So the universal law of gravitation explains that the force between the two bodies, which is one is bigger and another one is smaller, that two objects, how it will be getting the gravitation forces and how the distance will be impacts and mass will be impacts on the forces of these two objects. Now let me see the gravitational force between the larger mass, if you may consider this is as an earth mass, and a small object mass we are considering small m. Now the distance between these two masses, or if you consider as capital R, then what is the forces between these two? Means the first statement you are writing that the force, the gravitational force between these two is the product of masses is directly proportional to the force. I repeat, the product of the masses between these two is directly proportional to the gravitational force. And the second statement is the gravitational force is inversely proportional to the R. So that means R square. So why it is R square means from M to M is R1. Similarly from small m to capital M there is R12 or R21. So R12 and R21. So here this is one distance and this is one distance. The two are same. That means R12 is equals to R21 is equals to R. So therefore the product of R and R is R square. Now therefore from the first and the two, F is directly proportional to capital M small m by R square, and therefore F is equals to capital G capital M small m by R square. Here the G, capital G is the gravitational force constant. That's value of G is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. So this is the universal law of gravitation. The second question is, see, the second question we are going to discuss about the universal gravitational potential energy. We know the potential energy formula is PE is equals to mgh, but the gravitational potential energy is different. How it is differs means, by the definition it seems it is very different. That means if you consider the gravitational potential energy GPE, so GPE means gravitational potential energy. So the gravitational potential energy means if you consider the earth mass capital M, and this earth mass is having the field, it have the field around it some distance. Now in this earth gravitational field, if you consider a small m mass of an object, if you applied some external force on this object, if it travels for the distance of dr in that gravitational field, if you are applying the force on the object to displace or dr displacement by applying the external force F, then you are doing work is dW is equals to F into dr. So you are applying the external force is F on small m. Now why you are applying the force means just to get the displacement in the field of gravitation. Then dW is equal to F dr. Now both sides if you are applying the limits, then see integral dW is equals to integral F dot dr. Now we know that the gravitational force F, the gravitational force F is what? We know that in the previous session F is equal to capital G capital M small m by R square. From this equation, by substituting this value in this equation, now integration and differentiation gets cancelled, then W is equal to integral F means capital G capital M small m by R square into dr. So this value I have written here. Now simply this G capital M small m is always constant because mass is not varying with respect of time. So capital G, capital M, small m, I am taking as a common. Now integral 1 by r square, this dr I am writing as a dr because small r is equals to capital R because both are displacement. Now capital G, capital M, small m, integral 1 by r square dr you can write as integral x power n dx is equals to x power n plus 1 by n plus 1. Here this 1 by r square can I write r power minus 2 dr, then it becomes as r power minus 2 plus 1 by minus 2 plus 1. Then it becomes as r power minus 1 and minus 1, then minus 1 by r. So from this derivation of the integration, we can also write this 1 by r square as, what is the value here? Integral r power minus 2 dr is gets minus 1 by r. Now this value I can write here, then it is minus 1 by r. Now the gravitational potential energy is equals to minus capital G, capital M, small m by r. So this is the gravitational potential energy. This is the gravitational potential energy. Cosine. What is the relationship between small g and capital G? Here the relation between small g means acceleration due to gravity. This is an acceleration due to gravity. And capital G is nothing but universal gravitation constant. Universal gravitation constant. So what is the difference between, what is the relation between the acceleration due to gravity and universal gravitational constant? Now see the relation between small g and capital G. Now I can write that according to the Newton's second law, F is equals to ma, and we know that the gravitational force Fg is equal to capital G, capital M, small m by r square. And now see here, equating this first equation and this is a second equation. From equation 1 and 2, ma is equals to capital G, capital M, small m by r square. If I consider this a as an acceleration due to gravity g, then it is mg is equal to capital G, capital M, small m by r square. Small m and small m gets cancelled. Now small g is equals to capital G, capital M by r square. So g is equals to gm by r square, or you can also write g r square is equals to gm. So this is the relationship between small g and capital G, that is g equal to gm by r square or gr square is equal to gm, that we can write. You can see the fourth question is, what is escape velocity and what is the value of escape velocity and what is the formula for the escape velocity? You can see that the escape velocity of an earth, how you can define? Escape velocity means the minimum amount of velocity which is required to escape an object from the gravitational field is called escape velocity, which is denoted by the letter is v. According to the law of conservation of energy, the summation of potential energy and kinetic energy is constant, and the kinetic energy is equal to the potential energy, and that kinetic energy is equals to potential energy, but it is in opposite sign, because if kinetic energy is increases, potential energy is decreases. If potential energy is increases, kinetic energy is decreases. That means the energy is converting from potential energy to the kinetic energy. So based on that, we've written this formula, but we know that the kinetic energy formula is half mv square, and the gravitational potential energy minus, and we know that gravitational potential energy is minus g m by r, minus g mm by r. This is the gravitational potential energy. Previously we derived that equation. Now finally minus of minus, it is plus. So g mm by r. Therefore here it is half mv square. Now from this equation we can cancelize this small m and this small m. Then v square is equals to 2 capital G m by r. So this is the escape velocity square, and you can also write v escape velocity is equal to root 2 g m by r. This is one kind of formula for the escape velocity. And also we can substitute the gm is equal to, we know that g r square is equals to gm. In this previous equation we derived that g r square is equal to gm. So in this gm place we can also write g r square. Therefore square root of 2 g r square by r. Now this r and small r gets cancelled. Finally the escape velocity v is equals to root 2 g r. The here the product of g and r is directly proportional to the escape velocity, and the velocity of the escape velocity of the earth is 11.186 kilometers per second. This is the earth escape velocity. This is the escape velocity derivation. Fifth question is orbital velocity. So what is orbital velocity and how you can derive the orbital velocity formula? Orbital velocity means, if I consider a planet, I consider here it is Earth. So Earth radius is here r. Earth radius is from the center to here it is r. So Earth radius is r. Now the required amount of velocity to rotate an object, the required amount of velocity to rotate an object around the earth in certain height h, then the distance from the earth to the orbit is r plus h. Now if I consider the object which is rotating around the earth in a circular orbit is I consider as m, and the earth mass is m. The required amount of velocity for this m object to rotate around an earth is called orbital velocity. Now how we can find that orbital velocity means, we know that when the object is in a circular motion, then it has the centripetal force mv square by r, that is equal to the gravitational force. This is the centripetal force, and here the gravitational force Fg is equals to capital G, capital M, small m by r square. Now this centripetal force we are applying for that object, but this object is from which distance? R plus h distance. So here the F is equals to, what will happen? Centripetal force mv square by r plus h. Similarly the gravitational force Fg is equals to, in r place we have to write r plus h. So capital G, capital M, small m by r plus h whole square. So these two are forces, so that's why we are equating the Fc is equals to Fg, because these two are equal forces. Fc is equal to Fg. Then mv square by r plus h is equals to capital G, capital M, small m by r plus h whole square. Therefore here r plus h and here 1 r plus h gets cancelled. Small m and small m will get cancelled. This implies v square is equals to gm by r plus h. Gm by r plus h. According to the earth radius is very larger than the h. So we are neglecting the h. Therefore v square is equal to gm by r. We know that the gm is equals to gr square. Therefore we are substituting that value, v square is equals to, this is also we can write, or v is equals to, you can also write v is equal to root gm by r. You can also write like this, or you can also substitute that gm value of gr square in the equation, in this equation. Then v naught is equal to root of gr square by r gets cancelled. Finally it gets v naught is equal to root gr. This is the orbital velocity formulas. You can write in terms of g and r, you can write like this. And we know that the escape velocity v is equal to root 2 gr. Now this escape velocity you can also write root 2 into root gr. Therefore the escape velocity is equal to root 2 times of v naught. This is the relationship between the escape velocity and orbital velocity. And you can also write v naught is equals to v by root 2. This is the orbital velocity in terms of escape velocity. Now the sixth question is gravity at certain height. Gravity at certain height. So we need to find the gravity at certain height from the earth surface. Now I am going to consider the earth surface is like this. Now this is the earth having the mass capital M. From its center it has the radius r. But at certain height h, what is the gravity of an object M. So now from here to here the height is r plus h. So from the center r plus h, from here to here it is h. Now what is the earth gravity of an object mass M at this point? Now for that we need to find, we know that the formula G is equals to capital G, capital M by r square. But what about GH? GH is equals to, you can write GM by, at GH the R is differ. At G the R is, because at the surface of the earth gravitational acceleration is maximum G. But here we don't know, that I can assume like a GH. Now from here to here distance is R plus H. So that's why here I can write R plus H whole square. Now if I return GH by G value. Now GH is what? GM by R plus H whole square into G is GM by R square. 1 by G means R square by GM. Therefore GM gets cancelled. Now GH by G is equals to R square by R plus H whole square. Now from this equation I can take the R square by here R plus, can I multiply with R by R here? The value will not change. Here see R plus H whole square, R plus H, but here I multiplied and divided with R by R. The value will not change and the square will be applied same. Now here I consider the R square same in numerator, but in denominator I can take a common R. If I taken the common R, but it isn't coming out of the bracket, it will becomes as R square. Then see here R square is come out, there is 1 plus here it is H, and this R will come here. Now remaining is H by R. Now 1 plus H by R. Now R square gets cancelled. Now it will becomes as, can I write this is a 1 plus H by R whole square, 1 plus H by R whole square. This 1 by X square will comes X power minus 2. Then 1 plus H whole to the 1 plus H by R whole to the power of minus 2. This plus 2 becomes in numerator minus 2. Now it is looks like the binomial theorem 1 plus X whole to the power of minus n. Then it is becomes as 1 minus nx. By based on this formula, we can write this as GH by G is equals to 1 minus 2H by R. Because it is 1 plus X, it is power minus n. 1 minus n into X, here 2 into H by R. Now GH by G is equal to 1 minus 2H by R. This you can write as GH is equals to G into 1 minus 2H by R. So this is the gravity at certain height formula. This is the derivation. How to find the gravity at depth D? Now see, I consider the earth mass M in the radius of R. Now earth mass is M and its radius is from here to center to the surface of the earth is R. But here I consider what in D depth I consider a small point M. In D depth the object we kept. Now from here to here it is the distance is, see, from here to here it is R, then here to here it is R, from here to here it is also R. But now it is D, then what will happen from here to here? It is R minus D. It is R minus D. Now at this point what is the gravity? According to the G and capital G relation, G is equals to capital G capital M by R square. Now GD is equals to what will happen? GD is equal to also GM by here. In R square plus we can write R minus D whole square. See, R minus D whole square. Now we know the volume of the sphere V is equals to what? 4 by 3 pi R cube, because it is spherical. But we know the sphere of density of the sphere rho is equals to what? Mass by volume. But mass is equal to what? Well, density is equal to mass by volume. But we know that mass is equals to rho into V. Then mass is equals to rho into V. We know the V and we have to substitute that mass is equals to, now see, mass is equals to rho into, in V place we are writing this V is equal to 4 by 3 pi R cube. 4 by 3 pi R cube written. Now substitute this value in these two equations. Now see, small g is equals to capital G into capital M means 4 by 3 pi R cube into rho by R square. So R cube, R square gets cancelled. Now this implies G is equals to G into 4 by 3 pi R rho. It is the G value. Similarly, what is the value for GD? G into M Here it is m means again same 4 by 3 pi. Here r cube place we have to substitute r minus d. Then it is r minus d whole cube into rho by r minus d whole square. Because r square, it is r minus d whole square. R minus d whole square, r minus d whole cube gets cancelled. Now we are getting, this implies gd is equals to g into 4 by 3 by r minus d into rho. Now we are making that the ratio between the gd by g. Now see, finally gd by g is equals to, gd means what? G into 4 by 3 pi into r minus d into rho divided by g into 4 by 3 pi into r rho. Rho gets cancelled, g 4 by 3, g 4 by 3 gets cancelled. Now it is r minus d by r. This we can write as 1 minus d by r. Now here finally this implies, see here, gd by g is equal to 1 minus d by r. Then gd is equal to g into 1 minus d by r. So finally gd is equal to g into 1 minus d by r. So this is the gravity at certain depth.